So we're going to start with this line. You need to get a ruler, so I need to go grab mine. I think centimeters are easier to use than inches, so I'm going to use centimeters, and I would recommend using centimeters. How long is that red line on your computer? And you want to do it to like the nearest tenth. You want to write that in. So mine's like 1.8 centimeters. Whatever yours is, you can either use mine right now or you can find your own. It doesn't matter to me. And then we need to measure the height of that triangle. So if I measure the height of that triangle, I just put my ruler up to it, measure to the nearest tenth, and I get like 3.4. Then we're going to use Pythagorean theorem to find the hypotenuse. Anybody get the hypotenuse? That's 1.8 squared plus 3.4 squared, and then you take the square root. Mm-hmm. 3.85. So now we've got to do that 2 more times. So we can find this distance. And for me, it's like 6.4. And then we want to find this distance. Which looks to be 3.5. So what did we get for that hypotenuse? Exactly, 7.3. So we're just going to keep doing that. We need to find the 2 legs by measuring. This is going to be our smallest triangle, I think. So 2.2 is what I get. So you could, but if you measure them and you have a rounding error, then your trig isn't going to work out right. So it's better to measure the legs and then calculate with the Pythagorean theorem. If we could measure exactly, like if we had a piece of paper and it was easier to measure, I might be okay with that. So what do we get for the last hypotenuse? That green is hard to see. So now we've got our sides. Now we need to find some angles, and we find angles with inverse trig. So let's look for this angle, angle x. Do I want to use sine, cosine, or tangent to find x? And there's no right or wrong. We just need to decide. We have all the sides, so we can use any of them.
Sine.
Okay. For sine, we want opposite and hypotenuse, right? So if I'm going to do sine of x, I need the opposite, which is 1.8. That's the O. Over the hypotenuse, which is 3.85. That's the H. Because I'm looking for the angle, I really need to do inverse sine. So inverse sine of 1.8 divided by 3.85 gives me what? So you need to go over to your calculator, do inverse sine, 1.8 divided by 3.85, and we get what? Remember, your calculator needs to be in degree mode.
27.8.
Yeah, let's round these angles to the nearest whole number. So this is going to be 27.8 would round to 28 degrees. Because we know this other angle is a right angle, then what do these two acute angles have to add up to be? They all three have to equal 180, absolutely. And if I have a 90-degree angle in the corner, that means the two acute angles have to equal 90. So we can either do 180 minus 90 minus 28, or we can just do 90 minus 28 to get this other angle in the purple and pink triangle. So what is our missing angle down here? If I know 28 and I know 90, what's this missing angle? $62. Perfect. Okay, so now let's go do the blue triangle. We've already used sine, so now let's use either cosine or tangent. Which one do we want to use for the blue triangle? Yeah, so we're using the sides now because the sides are easy to find the angles. So the next one in line is cosine. Let's just use that. So I want to do cosine. I want to make sure the hitting and the leaving angles are the same. So let's make this one cosine of angle R is going to be adjacent over hypotenuse. Adjacent always messes me up, but I know that this is the hypotenuse. So I know it needs to be over 7.3. And I know the opposite side is this one, which means this one must be the adjacent, right? So 6.4. Because we're looking for that angle, we've got to do the inverse. So cosine -1, 6.4 over 7.3. Cosine, this is the math problem we need to put in our calculator and make sure we're in degree mode. Cosine -1 or inverse cosine, 6.4 divided by 7.3.
That's next. You see that's one.
The red 28. So in an ideal world, that's exactly what we want to calculate. Because we didn't use tracing paper, we didn't reflect that pink triangle up onto the blue triangle, we just kind of free drew it and eyeballed it. We've got to calculate to see if that's actually right. So when you calculate, when you do this inverse cosine of 6.4 over 7.3, what number do you get? I have to go on Desmos too, or pick up my calculator. So you want to make sure your calculator is in degree mode. If it's not in degree mode, you're going to get a weird decimal. You're going to get kind of a strange decimal anyway, but it should be close to 28. When you do inverse cosine 6.4 divided by 7.3, make sure you're in degree mode. $28.75. So we rounded to the nearest degree. So let's round it to 29. Our eyeballs were really good. We want those two numbers to be the same, and they're really close to the same. That's fantastic. Okay. So if I know the 29 is for the really acute angle, what's the size of this medium angle up here? Because we know all the triangles add up to 180 degrees. $71. 71? 61. $90 minus 29 is 61. Do we agree with that?
Yeah.
Okay. So now let's turn to the green triangle. Do we want to, let's find the angle opposite the 61. We'll look for this one. And we need to use tangent because we haven't used it yet. So tangent of the angle that we marked is going to be opposite over adjacent. So the opposite side is the 1.8 and the adjacent side is the 2.2 because adjacent is next door and opposite is across. So we're looking for the angle. So inverse tangent of O, 1.8 over 2.2. So in the calculator, we're making sure it's in degree mode. Inverse tangent 1.8 divided by 2.2 equals how many degrees? So in my calculator, this is what I'm putting in. Inverse tangent.
I got 29.
That's what I got, 39.2. And that's going to round to 39, right? So we had matching angles down here, the 29 and the 28, but here we didn't do such a good job of eyeballing it, right? The 61 and the 39 in an ideal world would be equal. What's our missing angle over here by the hole? If we've got 39 next to the wall and we've got a right angle, how do I find that missing angle next to the hole? 51, perfect. Because these two angles have to add up to 90 degrees because we've got a 90-degree angle over here. Or all three angles have to add up to 180. So as you go through the next two examples on slide 9 and slide 10, your goal is to get both pairs of angles to be about the same. If it doesn't work out, I'm not going to take off points. Don't worry about that. What I really want you to do is practice making the diagonals, drawing the hypotenuse, making the right triangles, measuring, using Pythagorean theorem, and then using inverse trig. Okay? The challenge part, which we will finish tomorrow, is going to be to make your own course. So I don't think I am going to add a Pear Deck. I think I want you to actually have to draw this with the Google tools. Okay? So I want you to make your own tomorrow and then show me how you would do it. Does that make sense?
Yeah.
So at this point, do you think you can work on these in groups and do them on your own, or do we need to do another example? Okay. You think we're good? Let's try it. You can always call me into your group, your breakout room, and then share with me your slides so we can talk about them. I think it'll be more fun to do them together in a smaller group. So if I make breakout rooms, do we want to go with our traditional choices? Amin, Jaquan, Mikhail, you guys want to be together? Okay. And then Faith and Esther, do you ladies want to be together? Okay. Who else? Daniel, Caitlin, Robert. These are kind of my 3 standard groups.
Yep.
Rory, Lovely, Justin. Don't see Justin in here. Am I missing Justin here today? Rory, Lovely, anybody else you want in that group? Brianna, Daniel, Evan, Josh, Liam, Riley, Sammy, William. Anybody else want to work together? Or do you guys all want to go in one big group?
To be honest, if you do put us in one big group, at least someone will team.
Okay. Okay.
Yeah.
All right, so I'm just going to put everybody else in this next group. And then if you guys want to work together, you're welcome to work together. And if you want to work alone, you can work alone. It is 9:35 and we get out at 10:10. So let me give you 35 minutes. And call me in when you need me. Daniel, did you have a question or have you gone back to sleep? been shopping. They were gonna start coming in. Do you wanna take it upstairs for me? Why don't you just bring it upstairs and stop trying to figure out what's in it?
One in this room or that? Thank you for listening to me.
Thanks, Ben.
Yeah, Steve.
Hey, how can I help?
About slide 13. Are we supposed to do that tomorrow or today?
You can start it today since tomorrow's a short day. So if you want to like build a picture today, then you can solve it tomorrow. But like the breakout rooms are going to end in about 23 seconds. So
20 seconds.
yeah, if you haven't done it already, it's probably too late now. But yeah, that's where we're going to start tomorrow.
Yeah, 30 minutes
Awesome. Who was working together? Okay. Okay, cool. I look forward to looking at those later today. And I'll see you guys tomorrow. Guys, that's it for class today. We'll pick up where we left off tomorrow. And I have started putting in grades, so I'm still going to go through the grade book. But you guys have a great day, and I'll see you tomorrow.
Yep, see ya. Bye.
Bye.
Bye-bye.
Mikhail, did you come back in because you had a question?
I got kicked out of the session. I didn't know what was happening.
Oh, gotcha. So class is over. It's 10:10. We will reconvene tomorrow and finish up these slides.
All right.
Okay? See ya.
You want to know what's crazy?
What's crazy?
I was just curious. Like, I do like know how generators would work, like, you know, like the
Really? Cool. Nice. On your computer? Sweet. Oh, okay. Uh-huh. Hmm. Wow.
Yeah, the one that's doing my job.
Oh, that's kind of weird. That's crazy. You know so much more about computers than I know. A month or just period? Oh, okay. Yeah. Agreed. Agreed. All right. I'll see you later. Daniel, I'm going to close the meeting so I can go to my next class and you need to go to yours, okay? See you later. Hey, Sterling, how are you? Morning, Elif, Ashley, Thomas.
Hello.
Ashley, how are you feeling? Morning, Aaron. Morning, Karma and Mariah.
Morning, Steve.
How are we today?
I'm okay. How are you?
Yeah, I'm good. It's almost Thanksgiving.
Do we need anything for class today?
You just need your ruler and your catapult. So I want to spend the first little while kind of playing show and tell with catapults, and then we're going to start into our project today.
We're going to start on what?
We're going to start into our problems today. I said project, I meant problems.
Okay.
Yeah. Oh, really? Does that mean you didn't test your catapult or you just didn't write in the numbers? Right. We were going to talk about that. So basically, my other one is downstairs, but this one, if you put it up against a protractor, the maximum angle that this one can get is 27 degrees, 25 degrees. And so if you just hold it up against your protractor, this is the angle. So at 27 degrees, I can't push it down. It's not going to launch anything. But if I take it down to 20 degrees, then it's going to launch something. If I take it down to 10 degrees, it's probably going to launch it further. And if I take it all the way down to 0 degrees, it'll probably launch the furthest. This one, the maximum is going to be that 25 degrees. It's not ever going to get to 90 because 90 would be if I unhooked the rubber band and it was like this. Does that make sense? So not all catapults are going to have numbers for all of the degrees. The degree comes from where you launch it from.
This catapult?
Yeah. Nice. Which one launches the furthest?
I believe this one go higher.
So one of them goes high and one of them goes long. Okay. Well, that is true, unless you took it outside. So who else has a catapult that they tested? I just want us to like spend the first couple of minutes of class playing show and tell. So you made one, Ariana, but not the other one? Okay. Which kind did you make? Yeah. So did you take some sticks out of it? How did that change how it launched? So it made it go further horizontally or higher, taller, or both? Both. Did it give you a bigger angle? Like when you pushed it down, did it give you like more room to move or less room to move? The tinier one, this one launches further than the other one? Interesting. So for those who have just joined us, if you have your catapults, I'd love to see them. Just kind of give me a visual. You can hold it up to your camera. I want to know which one launches furthest. Nice. Sterling, did you just use the green glue from the bridges to get the cups to attach? Or did you use something different? You're muted. Okay, so you had some hot glue. Mariah, which one of yours are, I think you're putting them back together. Is that what you're doing?
Yeah.
Gotcha. I didn't. It made it down to my garage, and then I never got the drill out to drill the holes in it. I know. I promise I'll make it. It just didn't happen over the weekend. I don't even know. I feel like I didn't do anything this weekend, but somehow that didn't get done, and I didn't realize until this morning, honestly. So I did walk my dogs. Sterling saw me walking my dogs. I live in the neighborhood behind the football field. So you know that cut through to go from the high school over to the rec? I live in that neighborhood. Yeah. So nobody else wants to share? That makes me so sad. Sad face. I can hear you, Ashley. What happened? Younger siblings? Oh. Drat. You need to eat some more ice cream. Okay. Gotcha. So what's the best way, like what's the best angle? And that's kind of what I wanted to get at. It's not really the best angle to go all the way down. It went furthest for you, Sterling, if it was all the way down? All right. All right. Okay. If you didn't finish yours, I need you to finish it. How far did it go? 30 feet? Wow. 30 degrees. Okay. 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 I was like, 30 feet. That's a long way for that little one. You can definitely get 30 feet, but not out of that one. No, we're gonna do something new today. All right, I'm gonna share my screen because I do have one thing I want to show you guys. I added this announcement schedules and slides, announcement schedules and calendar page to the top of our Schoology. I think everybody in this class, why is this not responding? Oh, there it is. Did the survey last, like maybe 2 weeks ago. So click on that survey. This is the really long one that we spent like half the class doing about colleges and AP classes and honors classes and all that stuff. Only about 40% of the school population has completed it. I'm pretty sure all of you did it. At least I gave you a lot of time to do it. If you click on this link and it lets you take the survey, then you have not completed it and it needs to be completed by tomorrow. If you click on the link and it says you've already completed the survey, then you are good to go. You've got nothing more to do. But this 100% has to be finished by next week. Otherwise, you're going to, or by the end of the day tomorrow. Otherwise, next week, you're going to start getting emails, if you haven't already, from admin. Okay? Office hours have moved to Google Meet. So that's the link there. We've got the announcement slides. This is the adjusted dismissal for tomorrow. So third block is going to be 9:40 to 10:35. 9:40 to 10:35. So if you show up at 10:15, you're going to be late. Okay, 9:40 to 10:35 is tomorrow's class. And then the class schedule for the rest of the year, or at least until it changes again. Okay, any questions about that? The survey and the schedule for tomorrow is what I really want you to see in that. The point of having a half day is we can still legally count it as a day of school because under federal rules, in order to be accredited, we have to have 182 days of school. Mm-hmm. So if we have a half day, it still counts as a day. That's the whole point. Yeah, I would agree with you. It does seem kind of crazy. It's all of these like laws and rules and regulations from the federal government. The answer to that. So again, if you haven't done your Catapult, haven't filled out the Google Doc, I have started putting in grades into the grade book. I apologize for being such a delinquent teacher. I hadn't put anything from this unit in. So I did start populating that and it will be up to date by the end of today. So we're not going to do a catch-up day today, but tomorrow you'll be able to let me know, hey, you missed this or, you know, whatever. And then over the weekend and on Monday, so virtual Monday assignment is going to be to catch up on any missing assignments because I'll have the grade book populated by then. But today is the 24th, so we're going to go to Angles of Golf. So everybody needs to meet me here. We are going to do this in Google Slides, and that's going to frustrate some of you, but I want you to be able to collaborate on this. So in order to collaborate, it needs to be in a Google Doc, not in a Pear Deck. So if you click on that, it'll take you to the slides. I already have one copy open, so I'm just going to open that. And we're talking about angles of golf, right? So angles of golf, you could also look at this like pool. If you shoot a ball against a wall, like in miniature golf or in pool, it's going to leave at that exact same angle. So if we were face-to-face, I'd give you some tracing paper and we would actually do this on paper so you could make sure that these two angles, the hitting angle and the leaving angle, are going to be exactly congruent. We don't have that, so we're going to estimate it today, and then we're going to check with inverse trig to see how close our estimations were. So I do a hitting angle and a leaving angle. The hitting angle and the leaving angle should be exactly the same. If I make some perpendicular lines, and we're going to draw those with segments, right, in Google Draw, then these should be right angles, which means these are right triangles. The hitting angle makes a right triangle and the leaving angle makes a right triangle, and those should be exactly the same. So let's see what that actually looks like. I've given you a couple of pictures of some fun miniature golf holes that maybe could exist. These are obstacles, so it can't go through those black lines. The small dot is where you start and the big dot is where you finish. So this is your golf ball and this is the hole you're trying to get it in. We've got to bounce it off a wall in order to get it to the other wall to bounce it into the hole. So we're going to have 2, 3 line segments that we're going to have to make. And we're going to try our best to make the hitting and leaving angles congruent. Does that make sense? Let's see what that looks like on slide 5. So I've drawn some arrows. I'm going to estimate that that's where I want to go, and then it's going to leave. D and X should be the same size. And then it's going to bounce off this top wall and into the hole, and Y and R should be the same size. So that's my goal. I'm just estimating with my line segments to make D and X congruent and Y and R congruent. So now we're going to turn those into right triangles. We make a little perpendicular line here that makes a right triangle. I already have a corner that's a right triangle, so the XY triangle is already right. And then I've got to make this vertical line here to make a perpendicular line with the wall, so the RS triangle is a right triangle. Okay, so all we're doing is making those segments into the hypotenuse, and then the wall and one more line to make a right triangle. Then we're going to go to the next slide and we're going to actually measure all of those. So we're going to measure the legs, right? We could also measure the hypotenuse, but we're kind of estimating with our ruler, especially on the computer screen. So what I want you to do is measure the legs and then calculate the hypotenuse using Pythagorean theorem. Okay. So in the next slide, you can see I measured everything. I measured 3.8 and 2.1. Use Pythagorean theorem, a squared plus b squared equals c squared, and a squared plus b squared equals c squared, a squared plus b squared equals c squared. I did my right triangles, that's a check, right? Then I've got to use inverse trig to find my angle measures. So if I start with angle C and I use cosine, it needs to be adjacent over hypotenuse to find angle C. If I use sine, and I start with R, then I need to use opposite over hypotenuse. Remember SOHCAHTOA. So 1.5 over 3, 1.5 over 3, that's going to give me angle R. Same thing with tangent. Tangent is O over A. Remember SOHCAHTOA. Sine, opposite hypotenuse, cosine, adjacent hypotenuse, and tangent, opposite adjacent. So in the next slide, I've calculated all of that. So I've got my Y, that's 67 degrees. I've got my X, that's 23 degrees. I've got D, that's 29. C is 60. Remember, those two acute angles are going to add up to 90 degrees because you already have 90 degrees here, and they have to equal 180. So these two angles have got to equal 90 degrees. You use inverse functions to find the C, and then just subtract from 90 to find D. The X and the D should be the same, but they're not. X and D should be the same, but they're not. They're close. My estimation was almost there, but the Y and the R are definitely not the same. Y and R definitely not the same. So this is not the real trajectory of my golf ball. This is not how it would hit, right? But it's close enough. So what we want to do is, I thought I erased all of that stuff.